Hello students, good evening all. Today we are going to discuss about the new chapter. So before going into the chapter, I just want to know whether the streaming is good, so you can just give the stars accordingly. Okay, so let's start the session. So first we are going to let's see what all topics we are going to discuss. So before that, I'm giving you a brief introduction regarding myself. My name is Roshan Ahamed. I'm your chemistry faculty and I have completed my BTech and MTech, and I was a national Olympiad winner, and I have 6 years of experience in this teaching field. Okay, so that's all about me. So today we are going to discuss about the mole concept. We know that mole concept is a very important concept regarding the physical chemistry. Okay, so you are preparing for JEE, we know that, and as far as a subject chemistry is concerned, we know that you have physics, chemistry and maths for JEE, and chemistry is the most important subject as far as JEE preparations are concerned, because it is a high scoring subject. So if you want to score around 150, 160, 170, the 30 questions from chemistry is going to give you 120 marks out of that. So it is the easiest, and as well as it's a high scoring. So you have to clear all your concepts properly. Then once you clear all your concepts properly, then everything will be easy for you. Okay, so now let's start with the mole concept. So we can divide chemistry into three. That is physical chemistry, the other is inorganic chemistry and organic chemistry. As far as physical chemistry is concerned, mole concept is the most important topic in the whole physical chemistry. Okay, so let's get started. We'll be starting with the base. Okay, before going to the classes, please ensure that you have subscribed to this channel, and in APJ Academy we will be coming up with classes regularly, so you can subscribe it and you can listen to the classes, and it will help you score good marks in your upcoming exams. Okay, so don't forget to subscribe. Right, now coming into the basics, let's start with the atomic mass. Okay, we know that atom is the fundamental particle of matter. And what do you mean by mass of an atom? We know that. Let's take an atom into consideration. Okay, let's take an atom into consideration. So I'm just drawing an atom over here. You can see that every atom consists of a central nucleus, and inside the nucleus we know that there are protons and there are neutrons. And around the nucleus we know that there are electrons are revolving around the nucleus. And what I want to say is that I'm talking about the Bohr model, not the other wave nature or the Heisenberg principle. I'm not going into there. I'm just explaining about the Bohr model, or to give an overview about the atom. So let's consider the nucleus is situated at the center of the atom, as Bohr has explained, and electrons are revolving around the nucleus. And we know that there are 3 subatomic particles present in an atom, and that is protons, neutrons and electrons. And let's considering atomic mass. We can consider that atomic mass is equal to the mass of the proton plus mass of neutron plus mass of electron. So we are considering an atomic mass, means the total particles present in an atom are neutrons, protons and electrons. So we can sum up the whole masses of the neutron, proton and electron to get the mass of an atom. So let's see, atomic mass is equal to mass of electron plus mass of proton plus mass of neutron. So we know that mass of proton, so I'll write it as MP, that is equal to 1.6 into 10 raised to minus 27 kilogram. Yes, kilogram. and mass of neutron is equal to nearly equal to 1.6 into 10 raised to minus 27 kilogram. And what about mass of electron? Mass of electron is equal to 9.1 into 10 raised to minus 31 kilogram. So if we consider all these three values, we can see that the mass of electron is so small that we can neglect this value. Yes, we can neglect this value. And mass of proton and mass of neutron is we can short them into, or we can say that they can be represented as 1 AMU, that is 1 atomic mass unit. So we know that 1 AMU is equal to 1.6 into 10 raised to minus 27 kilogram. So this value you have to remember it. So what is the mass of proton? Mass of one proton is equal to 1 AMU. What is the mass of neutron? Mass of neutron is also equal to 1 AMU. So now the equation is so simple that atomic mass is equal to total mass of proton plus total mass of neutron. We do not consider the mass of electron because mass of electron is so small that it should be neglected. Okay, so that's all about the atomic mass. Now we'll move to the next topic. That is, here I have told you that we only consider the mass of an atom as the mass of nucleons. Okay, what is nucleons? Nucleons means, just see this, nucleons means the particles present inside the nucleus. Particles present inside the nucleus. Okay, the particles present inside the nucleus is called as nucleons. What are the particles present inside the nucleus? It is, we know that it is protons and neutrons are present inside the nucleus. So we call protons and neutrons together as nucleons. Okay, now you can see that I have given hydrogen, carbon, nitrogen, oxygen, sulfur and sodium. Okay, so these elements I have represented in a particular way. You can see that there is a number below and a number above the letters. Okay, so the number that I have given below, that is H11, this number represents the number that is below, represents the atomic number. Atomic number. What do you mean by atomic number? Atomic number either can be called as, or we can define it as the number of proton, or it is also called as number of electron. Okay, now on the top you can see that this number is called as the mass number. Mass number. What does the mass number indicate? Mass number indicates the number of nucleons. Okay, what does the mass number indicate? Mass number indicates the number of nucleons present inside the nucleus. So in order to identify the mass of an atom, we only require the number of nucleons. So let's see. Here you can see that the hydrogen, the number of nucleons present in hydrogen is 1. That means the mass of hydrogen is 1 AMU, atomic mass unit. So let's take the second case. In the second case, you can see that I have given you carbon 12. So what is the mass of carbon? That will be equal to 12 AMU. Why 12 AMU? Because we know that mass of one nucleon is 1 AMU. Mass of two nucleons is 2 AMU. So mass of 12 nucleons is equal to 12 AMU. So what about the mass of nitrogen? Nitrogen is 14 AMU. What about mass of oxygen? Oxygen, it is 16 AMU. And mass of sulfur, you can see that it is 32 AMU. And mass of sodium, you can see that it is 23 AMU. Okay, this is all about the atomic mass. So now you got a clear picture how to measure or how to calculate or how to identify the mass of an atom. Mass of an atom is nothing but it is the total mass of proton plus mass of neutron. So what will give you the mass? It is the mass number that gives us the mass. So what is mass number? Mass number is simply just the number of nucleons, that means number of protons and neutrons present inside the nucleus. Is it clear? So let's move on to the next topic. Yes. Okay. Now Let's calculate the number of atoms present in 24 AMU helium sample. We know that considering helium, the mass of helium is 4 AMU. Okay. How did I know that? Because helium contains 4 nucleons. So if helium contains 4 nucleons, then mass of one atom of helium will be 4 AMU. Okay. Now calculate the number of atoms present in 24 AMU. So I have an helium sample. I have helium sample which consists of 24 AMU as its mass. So how many helium atoms will be present in 24 AMU? So let's see, number of helium atoms is equal to mass of sample divided by mass of one helium atom. So what will be the value? Mass of sample is 24 AMU and mass of one helium atom is 4 AMU. So you can divide that. 24 by 4 will give you 6. So we know that one helium atom is 4 AMU and 6 helium atoms means 6 into 4 AMU, total 24 AMU. So such type of questions can be asked. So you have to practice this type of questions. So let's conclude this, that is calculate, the question is calculate the number of atoms present in 24 AMU helium sample. So you have to calculate the number of atoms, helium atoms present in 24 AMU helium sample. So what is the equation to find out the number of atoms? The mass, given mass by atomic mass will give you the number of helium atoms. Hope that is clear. Now let's move on to the next. So let's see. What do you mean by a molecular mass? So we know that what is a molecule? Molecule is a combination of atoms. So if you add the mass of each atom, you will get the mass of a molecule. So what does mean by molecular mass? It is mass of one molecule. What is mean by atomic mass? It is mass of one atom. What is actually atomic mass is simply you can say that it is the combination of mass of protons and neutrons. We have already cleared that. Now what is molecular mass? Molecular mass is simply that it is mass of one molecule. So if you consider O2, we know that O2 is a molecule. So O2 consists of 2 oxygen atoms, right? So I have to add up the 2 oxygen masses of 2 oxygen atoms to get the molecular mass, right? So it is the sum of atomic mass of all atoms present in one molecule. If I say H2SO4, so let's see H2SO4. See, H2SO4 consists of 2 hydrogen atoms plus 1 sulfur atom plus 4 oxygen atoms. So if you add up the total sum of this, you will get the molecular mass. So hydrogen atom we know that it is 1 AMU, sulfur atom we know that it is 32 AMU, oxygen atom we know that it is 16 AMU. So if you total it, you will get the mass of H2SO4. So simply I have given you some examples. You can find out the masses. So let's say here I have given you oxygen molecule. Oxygen molecule, it consists of 2 oxygen atoms. So 2 into 16. So 2 into 16 will give you 32. That much AMU. AMU is the unit used to measure the atomic mass or molecular mass. Okay. Now take ozone. Ozone consists of 3 oxygen molecules, that is 3 into 16, that means 48 AMU. Now coming into sulfuric acid. Yes, sulfuric acid. In the case of sulfuric acid, we know that it consists of 2 hydrogens, so 2 into 1 plus 1 sulfur, that is 32, plus it consists of 4 oxygen, that is 4 into 16. So in total we get 32 plus 64, that is 96, 96 plus 2, 98. So 98 AMU you will be getting. Okay, so students, you also have to understand this. AMU has been replaced recently with unified mass. Instead of writing AMU, you can simply write U. You can simply write small letter u. This U means unified mass. Unified mass. So either you can use AMU, atomic mass unit. It's not a big deal. You can use that, or you can use unified mass. Now one more example is there, right? I have also given you about yes, chlorine Cl2, right? So Cl2, what is the molecular mass of Cl2? We know that one Cl atom consists of 35.5 AMU. So 2 Cl atoms means 2 into 35.5, that is equal to 71 U, or we can say 71 AMU is the molecular mass of Cl2. Hope this is clear. Now we will move on to the next topic. Yes, calculate the number of molecules present in 72 gram of water. Let's see. First, I have taught you the formula that to calculate the number of molecules, what is the formula? Or to calculate the number of atoms, what was the formula that we have discussed? It is simply, but it was simply that weight of the sample divided by atomic mass. Here we are discussing about the molecule, so we have to consider molecular mass. Okay, molecular mass of water. So the given fact is that they have given us a sample of 72 gram of water. So the given mass of sample is 72 gram divided by, we know that one molecule of water consists of how much mass? Just check this. We know that H2O consists of 2 hydrogens, so 2 into 1 plus 1 oxygen, that is 16. 16 is the mass of 1 oxygen and mass of hydrogen is 1. We have 2 hydrogens, so in total we get 18 AMU. So 72 gram it is given. So 72 gram is given. So we have to convert it into AMU. So I am giving you a relation between AMU and gram. So you have to note this very important relation, that is 1 AMU is equal to 1 by Avogadro number grams. 1 AMU is equal to 1 by Avogadro number grams. So here I have to convert this 18 AMU to grams. So 18 AMU I can write it as 18 into 1 AMU is equal to 1 by Na grams. So I can give it as 1 by Na grams. This much grams of water molecules are present. So dear students, you have to remember this relation. It is very important. 1 AMU is equal to 1 by Avogadro number grams. So I am just substituting the value here, that is 18 into 1 by Na. See, the numerator and the denominator should always contain the same units. You cannot divide a gram with AMU. Either you have to convert the gram into AMU, or you have to convert the AMU into gram. Whichever suitable you can use. Okay. Now 72 divided by 18 means 18 into 4 will give you 72. So I can cancel this. And I can give it as 4. So what will be the final answer? Final answer will be 4 into Na. 4 Na particles are present, or 4 Na molecules are present in 72 grams of water. Hope this is clear. Now we will move on to the next slide. Okay, now we are going to discuss about mole. Actually, this is what the important fact of this chapter. Okay, what do you mean by mole? Dear students, we know that we use certain terms to indicate certain number of particles. Say you go to a shoe shop and you ask the shopkeeper to give you a pair of shoes. You say that a pair of shoes. What do you mean by pair? Pair means 2. Or else you go to a supermarket and you will ask the shopkeeper to give you a dozen of eggs. So what does a dozen indicate? A dozen indicate 12. Okay. So similarly, if you are considering a chemical reaction, we know that the in a chemical reaction there will be a lot number of atoms and molecules are taking place, or a lot of molecules and atoms are participating in each reactions. So we cannot just use millions, even millions cannot do, billions cannot do. It is much more than that. So in such a case, we have to define a certain number which will be helpful for us and to the whole chemistry community to communicate easily. So such large numbers can be just represented with a single term, and that term is called as 1 mole. So what is a mole? Mole is just a counting unit or counting number. It indicates a certain amount of number. or it indicates a certain amount of quantity of number or quantity of units. Okay, it is a number, that's all. What is that number? 1 mole means it is 6.022 into 10 raised to 23. That means if I tell you that if this session is watched by 6.022 into 10 raised to 23 students, then I can say that my lesson have been watched by 1 mole of students. Okay, so what does 1 mole means? 1 mole just indicate the number, and this number is called as the Avogadro number. So this number is called as the Avogadro number. So what is Avogadro number? It is simply just 6.022 into 10 raised to 23. That is the number, and this number is called as the Avogadro number. And whenever a container or the reaction medium consists of this much of atoms or molecules, we can say that it contains 1 mole of particles. So 1 mole is simply but 6.022 into 10 raised to 23 units. Now let's get into the definition. What does 1 mole mean? 1 mole of any compound contains as many atoms present in 12 gram of carbon 12 isotope. 12 gram of carbon 12 isotope. So let's consider this. What does that mean? If you take 12 grams of carbon 12 isotope and you start counting the number of particles or number of atoms present in that sample. Okay, so why we have to take carbon 12 isotope? Because carbon 12 isotope is the element that mostly take part in the most of the chemical reactions. Okay, we know that carbon is an element which forms the largest number of compounds in the universe. So that's why we give preference to carbon. Anyways, we have to take any of the element to define this much units. Okay, so we are taking carbon in order to define this because carbon is the element which forms most of the compounds. So because we know that carbon have a good catenation property. So that's another topic. Now come back to mole. So what does 1 mole? Mole is that number which we get when we count the number of atoms in a sample of 12 gram carbon 12 isotope. So if you take carbon 12 isotope, 12 grams of carbon 12 isotope and start counting the number of atoms, you will be getting 6.022 into 10 raised to 23 atoms, and that quantity is called as 1 mole. So now the important equation is, what is the number of moles? How can you calculate the number of moles? See, for calculating number of moles, we have 3 equations. Okay, let's learn the first equation here. That is number of moles is equal to, see, number of moles is equal to number of particles given, divided by Avogadro number. What is Avogadro number? We know that it is equal to 6.022 into 10 raised to 23. So let's say I gave you a quantity. I gave you that this much of oxygen atom is present in a sample. X number of oxygen atoms present in a sample. And I am asking you to find out the number of moles of that sample. What you have to do? You have to use this equation, that is X particles divided by Avogadro number. That's all. Okay. So if you are asked to find out the number of particles by giving the number of particles, if you are asked to find out the number of moles by giving the number of particles in a question, you have to use this formula to find out the moles. Is that clear? Now let's move on to the next slide. Yes. See students, we have a Telegram channel, and you will get all the PDF materials, free classes, and all the announcements and our discounts and prices, etc. in that channel. If you want this offer, you can just join freely. You have a QR code on the screen. You can just scan it and get into our this Telegram group. Okay, it will be very much beneficial for you, so you can take that. Now let's move on to the next slide. Yes. See students, here we are going to discuss about a question. Here a question is given. A sample of ozone contains 8.66 into 10 raised to 23. It is 10 raised to 23 molecules. That 23 have been left out. Okay. So let's mark it here 23. Okay, so we have to find out the number of moles. So I have just told you, if the number of particles is given and you have to find out the number of moles, then what equation you have to use? You have to use this equation, that is number of moles equal to number of particles divided by Avogadro number. The number of particles is what? It is 18.066 into 10 raised to 23, and it should be divided by 6.022 into 10 raised to 23. The numerator, the 10 raised to 23 in the numerator and denominator can be cancelled, and this can be cancelled because 6.022 into 3 will give you 18.066. So the number of moles is equal to 3 moles. Now you got the answer. Now another question, the B part, let's see that. Number of atoms of oxygen present in the sample. So let's see. We know that here it is not about the molecule. Just see, you should be very careful about this. It is about the number of atoms. So let's take 1 mole ozone. So you know, before that we can just take 1 molecule ozone, right? Yes, we will take 1 molecule ozone. Okay, 1 molecule ozone contains 3 molecules, or sorry, 3 atoms of oxygen. 3 atoms of oxygen. So we can take 1 mole ozone. 1 mole ozone contains, we know that 1 mole ozone means 6.022 into 10 raised to 23 molecules of ozone. That's why we call it as 1 mole. Whenever you see mole, you have to understand that it contains 6.022 into 10 raised to 23 molecules of ozone. So I can write 1 mole ozone contains 3 into 6.022 into 10 raised to 23 atoms of oxygen. But the thing is, the sample given, we have calculated the number of moles. It is not 1 mole of ozone, it is 3 moles of ozone. Now we are going to take how many oxygen atoms are present in 3 moles of ozone. That will be, you have to multiply 3 here. So 3 into 3 into 6.022 into 10 raised to 23 atoms of oxygen, and this is the answer required. So you can write it in the short way, that is 3 into 3 is 9, and instead of 6.022 into 10 raised to 23, you can just simply write it as Na, that much atoms of oxygen. So hope this question is clear for you. So remember this, whenever the number of particles is given, how to find out the number of moles? Just divide that number of particles with Avogadro number, you will get the number of moles. Okay. Now when the number of atoms of oxygen is asked, here we have taken the sample in the form of molecule, that is ozone molecule. So first of all, you have to convert that ozone into number of atoms. So 1 molecule of ozone contains 3 atoms of oxygen. Then we convert them into 1 mole. So 1 mole of ozone contains Avogadro number of ozone molecules. That means 3 into Avogadro number atoms of oxygen. Now in the question we have obtained that it consists of 3 moles of ozone. So we have to multiply it with 3. So 3 into 3 into Avogadro number atoms of oxygen. Hope this is clear. Now we will move on to the next topic. Yes, molar mass. Let's see students, molar mass is represented in 2 ways. That is, yes, molar mass can be represented in 2 ways. That is gram atomic mass, or gram molecular mass. Gram molecular mass. Dear students, what do you mean by molar mass? Molar mass is simply the mass of 1 mole of compound. What does that mean? Mass of 1 mole of compound. What do you mean by 1 mole? I have already told 1 mole means it contains 6.022 into 10 raised to 23 particles. Okay. Now let's come into an interesting equation. See students, here we'll take a new page. See, we have seen that 1 atom of oxygen, one atom of oxygen is mass of one atom of oxygen. Mass of one atom of oxygen is 8 AMU. How much? Sorry, 16 AMU. It consists of 16 nucleons. So we can say that it 16 consists of 16 AMU. Yes, yeah, 16 AMU. Okay, 16 AMU. Okay, okay, right. Okay, right. Now, if I tell you what is the mass of 1 mole oxygen atom, 1 mole oxygen atom, it is very easy to calculate. Just convert the 16, just write 16 and put the unit as gram. That's the only difference. So how interesting is the equation? Mass of one atom is 16 AMU, then mass of 1 mole oxygen atom is 16 gram. That's the only difference. So now I give you another one. Mass of one molecule O2 is equal to 32 AMU. What about mass of 1 mole O2? Just convert that AMU to gram. Now consider this. What is mass of 1 H2O? We know that it is equal to 1 molecule H2O contains 18 AMU. 16 AMU of oxygen and 2 hydrogen atom, that is 2 AMU. 2 AMU plus 16 AMU will give you 18 AMU. So what will be the mass of 1 mole H2O? It is simply 18 gram. So the equation is so simple. What do you mean by gram molecular mass? Gram molecular mass or gram atomic mass both indicates the mass of 1 mole compound. And here for JEE, normally there is a twisted question which comes from this segment and students find it difficult to answer because it is a bit confusing. So I'll get into that. Let's take a new page. That is gram atoms or gram molecules. There is a representation of moles in these two manner. If I say 4 gram atoms or 16 gram molecules, the students normally consider that the weight is 4 gram atom. The weight of the given sample is 4 gram. It is not like that. Whenever you find gram and atom together, understand it is indicating mole. That means this sentence indicates 4 moles. It is nothing regarding the weight. It indicates 4 moles. So this is a very much confusing topic. So you have to feed this into your mind that whenever gram atoms or gram molecules are used, it only represents moles. So when I say 14 gram molecules, it is indicating 16 gram molecules. Gram molecules are coming together. That means it is just 16 moles. So you should be very, very aware of this concept, because if I tell you what is the, if I give you a question like 4 gram atoms of helium, 4 gram atoms of helium, in 4 gram atoms of helium, what is the number of helium atoms present in the sample? So dear students, here gram and atoms have come together. See, gram and atoms have come together. That means this in total they indicate nothing but moles. So that means it consists of 4 moles. So 1 mole means it consists of 1 Avogadro, 6.022 into 10⁻23 particles. So for what about 4 moles? 4 mole means it consists of 4 into Avogadro number atoms. That much atoms is present in the sample. So always be aware of this type of representations. Gram atoms or gram molecules is simply, it denotes the number of moles. Okay. Now let's move on to the next slide. See students, this is the second equation to find out the number of moles. The first equation was, you have to remember that the first equation was when the question is given in terms of number of particles, then number of moles is we use this equation to find out the number of moles, that is number of particles by Avogadro number. That was the previous equation. Now let's check this out. Here we are giving the mass of a sample, that is weight of the sample is given. Now how to calculate the moles? The moles can be calculated by weight of the sample divided by molar mass. Weight of the sample divided by molar mass. Now let's check this question. In this question, you can see that 24 gram helium sample is given. 24 gram helium sample is given. So weight is already given. So weight is given as 24 gram. And what is the gram atomic mass or the gram molecular mass of helium? We know that 4 AMU is the atomic mass. So we have to convert them into molar mass. For molar mass, helium consists of, what is the weight, what is the molar mass of helium? Just convert that 4 AMU to 4 gram. That's all. Okay. So what is the number of moles? Number of moles is equal to weight by molar mass, that is 24 by 4 equal to 6. It consists of 6 moles. That particular sample consists of 6 moles. Okay, find the number of moles of sample is given as 6 moles. Yes, we got the answer as 6 moles. Now what is the B part in the question? You have to find out the number of atoms present in the sample. We know that if it consists of 6 moles of helium, means helium is in atoms only. So 1 mole, we know that it is equal to 6.022 into 10 raised to 23 particles. So what about 6 moles? It is simply but 6 into Avogadro number atoms. So the answer is, you can write it here. Maybe you may not be seeing the answer. That is 6 into 6 into 6.022 into 10 raised to 23 helium atoms are present in the sample. Hope this is clear. So instead of writing 6.022 into 10 raised to 23, you can just represent it as Na, Avogadro number. So 6 moles is the answer. How many number of moles or number of moles present in the given sample? We have find out the answer as 6 moles. No, now the question in the second part, it was asked as number of atoms present in the sample. So if we have 6 moles, then just multiply the Avogadro number to get the number of particles. Clear? Now let's move on to the next question, that in 96 gram of ozone sample, yes, 96 gram of ozone sample, find the number of moles of sample. You have to find the number of moles. What is given? Given is the weight of the sample is given. So what is the formula? Formula is equal to weight by molar mass. Weight equal to 96 gram. What is the molar mass of ozone? We know that mass of ozone is, it consists of 3 oxygen atoms. That means 16 into 3, 48. 48 AMU is the mass of one molecule, but we have to calculate in terms of molar mass. So it is 48 gram. So you can just simply write 98 divided by 48. You will get it as 2. So number of moles is equal to 2. Now what is the second question? Find the total number of molecules present in the sample. See, we got the answer as 2 moles. So if the sample contains 2 moles, how many molecules of ozone is present? We can simply write 2 into 6.022 into 10 raised to 23 molecules of ozone. Say if I give you another question, that is the C part, that find the number of atoms present in oxygen atoms in the sample. So how you are going to find out? We know that one ozone molecule consists of 3 oxygen atoms. So here molecules of oxygen can be written as 3 atoms of oxygen into 3 atoms of oxygen. That means 2 into 6.022 into 10 raised to 23 into 3 atoms of oxygen. That means in total you can represent it as 6 Na oxygen atoms. 6 Na oxygen atoms. What do you mean by Na? Na is nothing but Avogadro number. 6.022 into 10 raised to 23. Yes. Now let's see regarding the volume. Now I have previously told you there are three equations to find out the number of moles. The first equation was when the number of particles is given and we are asked to find out the number of moles, then we have to find out by using the equation number of moles equal to N equal to number of particles by Avogadro number. Then the second equation was if the sample was given in terms of mass, then how you have to find out the number of moles? Number of moles is equal to mass of the sample divided by molar mass. Okay. Now the third one is regarding the volume. If I give you a sample and it is represented, the quantity is represented in volume, and if I ask you to find out the number of moles, then you can find out by volume divided by 22.7. If you use this equation, you can easily find out the number of moles if the volume of the sample is given. So from where I got this 22.7? Dear students, you have to understand 1 mole of an ideal gas, it always occupy 22.7 liters of space or 22.7 liters of volume. So whenever you take 1 mole of an ideal gas, that particular ideal gas will always occupy 22.7 liters. Okay. So 1 mole corresponds to 22.7 liters of volume. So if the volume of a particular gas is given and if you are asked to find out the number of moles of that gas, just use the equation V divided by, that is volume divided by 22.7, then you will get the number of moles of that given sample of gas. Okay. Now I wanted to introduce you a term that is STP. You can see here that means standard temperature pressure. Just remember the value of standard temperature pressure. In the case of standard temperature pressure, the temperature is 273.16 Kelvin and pressure is taken as 1 bar. Okay, these two values you have to remember it. So what do you mean by standard temperature pressure? It is the temperature and pressure condition. What is the value of temperature? It is 273.16 Kelvin. What is the value of pressure? It is equal to 1 bar. So hope this is clear for you. Now we'll move on to the next question. Let's see, students. Here you can see that the sample is given in terms of volume. That is, it consists of 44.8 liters of ozone. Now you are asked to find out the number of moles. So we know that if the sample is given in liters, then we can easily find out the number of moles by dividing it with 22.7. Okay. In certain NCERT text, in the old NCERT text, it is given as 22.4. You can use either of them because the STP condition previously we used was pressure was taken as 1 atm. It was not in 1 bar. It was taken as 1 atm. So we use, there will be a slight change in the volume. That is, if we are considering the standard condition of pressure as 1 atm, then the volume will be 22.4. Now the latest convention of IUPAC have informed that they are using 1 bar as a standard pressure. So if you are taking 1 bar as a standard pressure, then there is a slight change in the volume, that is 22.7 liters. So either you can take 22.4 or 22.7, there will not be much change. So if you divide 44.8 divided by 22.4 or 22.7, you get an answer nearly equal to 2. So calculate the number of moles means the number of moles we got it as 2. Now what is calculate the mass of sample? Now see, this is an interesting question. You got the number of moles and you are asked to find out the mass of sample. We know that number of moles is equal to weight by molar mass. So here they are asking us the mass of the sample. That means we have to find out the weight. So what is weight here? Weight equal to number of moles into molar mass. What is weight? Weight equal to number of moles into molar mass. So here number of moles is 2 and molar mass is, here the sample is ozone. We know that mass of 1 mole of ozone is 16 into 3 grams, that is 48 gram. So I can write it as 2 into 48 gram, that is equal to 96 gram. Okay. So we got the A part and B part is 96 gram. Yes. calculate the number of ozone molecules. So we have to calculate the number of ozone molecules. See, we know that number of moles is equal to number of particles by Avogadro number, and we are asked to find out the number of molecules. We have to find out the n. N is equal to number of moles into Avogadro number. That means number of moles is 2, Avogadro number is 6.022 into 10 raised to 23. So that much ozone molecules are present in the sample. Now let's see the question. So let's mark it here. Number of ozone molecules is equal to 2 into 6.022 into 10 raised to 23 ozone molecules. Now the last question is regarding calculate the number of oxygen atoms present in the sample. So how to calculate the number of oxygen atoms? We know that one ozone molecule, we know that this much ozone molecule is present, that is 2 into Avogadro number ozone molecules are present. We have to calculate the number of oxygen atoms, right? So one ozone molecule means one ozone molecule contains 3 oxygen atoms. 3 oxygen atoms. So what will be the number of oxygen atoms? The total number of ozone molecule into 3 oxygen atoms. So we get an answer as 6 into Avogadro number oxygen atoms. 6 into Avogadro number oxygen atoms. It's a very good question. And we have discussed all the topics that we have discussed earlier have come into this question. Just this single question, if you can do it, that means you have understood all the previous topics, all the previous concepts that we have just discussed. Okay? Yes, students. Now that's all about today's class, and there is a CRACH program going on. That CRACH program, we have 90 plus classes, and its duration is until the date of the exam. You can see that, and all the syllabus is covered from by the JEE experts, and we normally use the flipped classroom method with a better mentorship program, and there will be also doubt solving practice sessions will also be there. So this whole package we are doing in the case of CRACH course. So if you are interested in the CRACH course, you can just join the CRACH course. Okay, now yes, now let's see this, students. We have a subscription plan that will suit you. Okay, we have interactive live sessions, and we have structured classes, courses and PDFs. We have live tests, and physical notes will be given. I have already told you we have a mentorship program, that is one-on-one mentorship program is there, and we have live doubt solving sessions, and mock tests will be conducted regularly, and will be additional special courses will also be given. And we have 2 subscriptions, that is one is Smart and the other one is Profit. Okay, yes, students, this is how the closed classes looks like. We conduct the theory classes will be there, the study materials will be given to you, we'll be having live webinar, and the homeworks will be given, and we'll be checking all your homeworks. So first the theory sessions will be given to you, then we will supply you the study materials. You have to go through the study materials, and then a live webinar will be there to for the doubt clearance and the other any other issues with the subject or any conceptual clarity is required. There will be webinars which will support you with that, and we will be having a homework or the daily practice problems will be given to you, and that will be properly checked by the mentors. Okay, this is how the classes looks like, and there is a special price for Smart plan. You can see that the normal price is 7,990, and if you are joining today, then you can just purchase it for 2,990 rupees. Okay, students, that's all for today's class. Hope the concept is clear for you. We have discussed about the mole concept, starting with the atomic mass, discussing about the molecular mass, then the concept regarding the molar mass. We have discussed all the topics that is related to the mole concept, and we have done certain important questions which will clear you all your concepts, and hope this class will be beneficial for you, and we will see you in the next class. Until then, bye bye and take care.